Good morning to one and all present. My paper ID is 673. The paper title is Analyzing Machine Learning Techniques for Software Defect Prediction, a Comprehensive Performance Comparison. So myself, Sai Krishna Kunda, working as software engineer in Home Depot, Atlanta, Georgia, USA. From this work, we have taken the dataset from the Kaggle. The name is JM1 dataset, which is actually prepared by NASA and it is openly and publicly available. And applied various boosting techniques for classifying the given dataset, and then the performance has been compared, and we found that the XGBoost giving the highest validation in among all the boosting, and in case of accuracy, that boost is slightly better than the XGBoost and Lightboost. This study can be extended in various aspects. First one is we can add the hyperparameter and optimization can be included. So this is the overall abstract of this particular one. Coming to the introduction, so software faults are the imperfection that can lead to the software failures. So sometimes it is not meeting the requirement given by the user, and before we are giving the software to the user for the user experience, we need to rectify the defects. So the importance of software detection is predicting the software detection in an earlier case or in the earlier stage is very important, so that we can maintain the quality of the software in a additional way. So major machine learning techniques, both the traditional way and machine learning approaches has been applied in this one. If we are using the machine learning based things, that will reduce the time on analyzing and finding out the defects in an earlier stage. The traditional method always take longer time than the machine learning methods. Here we focused on the machine learning classifiers like gradient boost, data boost, XGBoost, light GBM, and cat boost for predicting the software. So this is about introduction, and this is the workflow. We have collected the data set from the Kaggle, and pre-processing has been applied, and then feature selection has been done. Then we splitted the data into training and testing, and then model has been trained. Then finally models evaluated, and the performance of the each model has been compared with each other to find out which one is giving the better result in the taken. Some of the related works already what we have identified is the major portion of the work has been concentrated on detecting the fault by the software engineer software, and key findings are size and complexity metrics such as KLOC, and these are all the things that has been used by many researchers. Here also we have used the similar pattern for analyzing the machine learning techniques. Already the techniques like SVM, K nearest neighborhood algorithms has been used by the reviewer researchers, and they have achieved some point of metrics and some point of accuracy in there. And they recommended to use the various combinations of algorithms like random forest and large fuzzy logic things in the upcoming researches also. These are all the findings we have observed from the related works. Keeping these as the base, and we propose the methods. The dataset has been applied to the data pre-processing. First, we find out some of the missing values. So we handle using the missing value. We replacing these things with the mean value of the particular thing because we are using the value, and feature selection has been applied, and finally normalization has been applied in the data pre-processing. Once the data is ready for the next step, it has been given into these models separately. So first gradient boost has been applied, and the results were taken, and it has been kept saved and separately, and then for ADA boost, similarly for the remaining methods we have used. These are all the achievement results we achieved. First one is accuracy. Then F1 score, recall, precision, and Jacquard has been applied. So both comparison and the tabular format and the graphical format is given here. So we found that CatBoost is giving second best accuracy, and XGBoost is giving first accuracy. But when compared to the other algorithms, also the variation is very less, very similar only. When compared with the other algorithms, XGBoost is giving higher, and LightBoost, CatBoost is giving lesser, and below to this Light GBM is there, and boosting, gradient boosting and ADA boosting having lesser value when compared with the other algorithms. So finally, the conclusion of this work is, so XGBoost achieved an accuracy of approximately 8.8437 across the tenfold cross validation, and then Light GBM also performed well. It achieved 0.8466, and the gradient boost is having lesser, and ADA boost also having lesser value when compared with the other type of algorithms. And finally, CatBoost is having the highest accuracy value of 8.8508 accuracy level. Okay. So in this work, what we done is we have taken the dataset JM1 dataset from the software fault detection. It has the entries which is already noted down by the NASA, and it is publicly available. And we applied the data pre-processing method like missing value handling and pre-processing and feature selection, and finally normalization has been applied. And we used five different boosting algorithms for predicting the software fault, and we found that CatBoost and XGBoost is giving highest performance than other algorithms. And in the upcoming work, what we done planned is we are planning to apply the ensemble method, so that we can find in each and every evaluation parameters what is the best way we are trying to get that. Thank you. Thank you for giving us this opportunity to present our work in your conference. Thank you, everyone.